The way we render on canvas is using double buffer mechanism for fast animation ones. First, the term render is in computer graphics term, so drawing on the computer screen is called the render. If it's text, we say displaying on this console or screen, but render is a computer graphics terminology. So how to render is as follows. So we have a screen here, and then we know that CPU runs the code. So for CPU, draw something on screen is a very slow process compared to CPU using the computer memory, where you do some arithmetic operations or function call and many like. So memory is a very fast for CPUs, but drawing something on screen is a very slow process. So what we do is use of a graphic processor unit called a GPU, and here is some special graphic memory is there. And the graphic memory is specialized to display something on the screen. So to make the drawing faster, so the technique is having a double buffer in graphics memory. So we have one memory and then another memory. So we have a double buffer. So using double buffer, what it does is that a CPU writes all the data to be drawn on one of the double buffer memory. And then this is a fast process because the CPU is writing onto the memory. And then when this all of the data to be displayed is already in the video graphics memory, GPU dumps that on the screen, and then GPU is a special processor for video graphics, so it's quite fast. Then while GPU is dumping the current contents on the screen, CPU is preparing the next thing to show in another double buffer. So it just keep doing so. So by doing so, the graphics are if you change it very frequently, it's done very smoothly. So game as motion pictures and then animation-based games typically use the double buffer mechanism to draw something on the screen. So in this game engine, we are going to put everything in game data, which is the things to be displayed on the screen. So in the canvas, we are going to use a double buffer mechanism to put everything from game data into the one of the double buffer, and then GPU dumps that, and then CPU prepares for the next one, and the like. So what I'm going to write in the render method is quite technical ones, so we may not be able to understand all of those details, but this is just the typical setup for use of a double buffer, and then I will let you know where you should put to draw something on the screen from game data, so we can just focus on that part. First, the canvas width and height is determined only when the canvas is rendered on the screen. So as you create my canvas object inside the computer memory, the size of the canvas is unknown, so we better have a width of the canvas and the height of the canvas are readily available as a public member of my canvas. So when the canvas is rendered, if any part of the game needs the size, it could be easily accessed. For example, the UFO flies across, then we need to know the width of the canvas. If UFO reaches the right end of the canvas, it should bounce back and the like. So width is known by call get size method, and then there's a width member there. Similarly, height, once it's rendered, we can call get size method and then height there. So at runtime, they are available. First, let's create off-screen double buffer image to for the CPU to create the things to be displayed on the screen. So that is done by having image object double buffer. Let's call it double buffer image, and an image I can import that AWT. That is by calling create image method and then giving size, so width and height of the canvas. That's the side we need. So just double check if this is null, something went wrong, so we cannot proceed. Just let's print message saying that critical error, double buffer image is so just something went wrong, so we cannot proceed. Let's just exit the program, something like that. Once double buffer image is ready, then we do off screen rendering, means that the CPU writes the next screen data onto this double buffer image. That is done using graphics image from double buffer. So graphics 2D, it's a G2 off screen image. We can call graphics 2D typecast. So double buffer image get graphics. Actually, get graphics returns just the graphics object, but actually it's a graphics 2D, so you can typecast it without any problem. Also, we better double check that if it's null, something went wrong, so we cannot proceed. Saying that critical error, G2 off screen is null, then we should quit the program and the like. Now the off-screen double buffer image is ready, so let's initialize the image. Buffer is G2 off screen. We call set background. So we want to have the background, and then color class defines some predefined color object. So let's have a black screen, and then clear everything there. So it's we need to specify a rectangle. Width, height, the entire canvas is cleared with the background color black. Now render, image buffer is ready. Render all game data there. So that should be taken care when game data part is ready. So here we just render that. Once the rendering is all done, we need to have a GPU render the entire graphic image onto the screen. So that part we write the code as follows. Use active rendering to put the buffer image on screen. So that process is as follows. Using graphics object, graphics on screen, let's call it there. So we are going to get graphics. So G on screen is from the current canvas or JPanel. Let's call get graphics. So that represents the current active screen. If G on screen is not null, if null we cannot do that, then what you do is a copy off screen image to on screen there. So G on screen draw image method call, and then double buffer image, then give xy 0, and then the last object is observer, so we don't need that, just call null. So that's what you do. Then we need to synchronize the display on some system. So this is for some system dependent issue. We do this one, but we don't understand exactly why we need this though. But get default toolkit sync, just call it. The purpose of doing so is sync the display on some systems. Then if on screen is not null, then what you do is G on screen dispose that since we have displayed everything on screen, so let's just display the buffer image for next user. So that's what we need to do. Then by doing this way, we set up the use of a double buffer. So all we need to do is at this moment, whatever you want to draw on screen, you should just do that here. So let's just for testing purpose, let's do one thing. So what you do is G2 off screen, it has lots of method there. Let's try to here is a list of things is there. Then let me choose a draw oval. Oval shape you can draw. So X and 100, 100, Y, and then width, height there. So you draw one oval with the same width and height, so you will see something like a circle there. So let's test up to here. Game loop, we have some negative one. So here, since we are not doing anything actually, so we should actually do double check if sleep time is only positive, do the sleep. So I'll fix that. Then we need to set the color of the oval. So here on canvas, so we draw oval, but since it's a black color by default, set color is color red, like then red oval will be drawn. Here is that the red oval is drawn there. It looks like it's just drawn once, but in actual program we are doing that within the game loop. So what it does is that at this moment the render, we draw a circle and then keep doing so. 20 frames per second is maintained. So here anyway we have those basic setup of the game loop. Here is some typo. Let me change it to correct the spelling there. So in the next several videos we will continue to develop this game engine.